Good afternoon, everyone. My name is Dio Keitan, has already been presented from IMAGIC, and I'm here to present you our first product, MagCyte. We developed this product to tackle a worldwide need, which is early cancer diagnostics. And we want to tackle this need to a point where cancer is no longer a concern. Can you imagine a world where you don't have to worry about cancer? I can, we can, and I'll explain to you in a minute why. But for now, we're still in the present, and cancer still kills 9 million people out of the 14 million new cases every year. That's why I'm almost sure that in this place, everyone has either themselves gone through cancer or has someone in their family or close friends who has. I know I had a close experience with cancer in my family, and I'm really worried because the numbers are increasing. Why is cancer so bad? Well, these are the 4 worst cancers, the ones that kill the most, and it immediately jumps to your attention that lung cancer kills more than the 3 others combined. Why is it the case that lung cancer kills so much? The big problem with lung cancer is that when symptoms do start to manifest themselves in your body and you go to the doctor, it's usually too late. It's already in an advanced state. Part of the problem here is that the detection mechanisms, in this case tomography, only detect cancers that are already too large. This means that if today I raise some awareness in the case of lung cancer and you decide to go tomorrow to the doctor, you might get a tomography, it will be negative, and you can still have cancer in your body. That's why only 17 to 22% of the people survive more than 5 years after being diagnosed with cancer. But, of course, there's a light at the end of the tunnel. To understand and to see this light, we need to know how cancer spreads. And what happens is that this very small tumor, again, it cannot be detected with imaging, it is already shedding some small cells called circulating tumor cells. These circulating tumor cells will flow in your bloodstream. They will go to a secondary location and they will create a metastasis. The thing is, for this to happen, the cells actually have to be in your bloodstream for an amount of time. So if we take a blood sample, just a simple blood sample, and we perform a liquid biopsy, we can detect these circulating tumor cells 4 years before it's actually visible in your body. This is groundbreaking, and this is why in the near future, every oncologist will prescribe a liquid biopsy for high-risk populations and for patients that have already been diagnosed with cancer before, during, and after the therapeutics. The attempts that have been made in the past to do the same are these 2 large equipments that you see here. What they do is that they collect the CTCs with magnetic markers, and then they have to remark these CTCs with fluorescent markers and use very, very expensive optics to count the cells. So, how do we, IMAGIC, or MagCyte by IMAGIC, solve this problem? We take the good functionalities of these 2 equipments and we put it in a very small 2x2 chip, microfluidics chip. How do we count the cells? We use the same magnetic markers that they use, but then we do not need optics because we have our magnetic sensible sensors. And what they do is that they act like a toll booth in a highway. So when we put the blood inside our microfluidics, the cells cross these toll booths and they are counted. By the end of the process, we also harvest the cells, and you'll know why that is very important, to keep the cells alive in the end of the process. This is our lab prototype. You can see that it's battery operated for point-of-care medicine, and those on the left are the cassettes that we will sell to make the tests. They are disposable to avoid sample contamination. This is our concept heart. So the cassettes will fit in that blue lid, and we're still working, of course, in the art. We are also working on the patents. We're working on the patents for the microfluidics, for the electronics, and for the sensor layouts. Of course, we have a competition. I've already told you about it. And how do we fare against them? I'd like to call your attention to the harvesting part. So why is harvesting important? We count the cells the same as they do, but then in the end we give the physician the possibility to study the cancer further so that it can treat you with a treatment that is adequate for your cancer and not just for everyone else's. I also want to call your attention to our production cost compared to their production cost. It's 20 times less. You might think that price is not important because lives are at stake here. But I tell you, and our contacts tell you, cost is definitely a major constraint in modern oncology. Of course, the market is really large. We will target the lung cancer early diagnosis, which is calculated to be worth 3 billion euros and growing at a 26% growth rate. To achieve these markets, this is our roadmap. So in the past, we've already spent about 1 million euros, either from FCT and EU, to get these prototypes working to the point they are. We are looking now for 250,000 euros to build our minimum valuable products, take care of the patents, and then we are asking for 4.5 million euros to take care of the regulatory path, both in Europe and in the United States. We'll reach in 2020, or we'll be able to sell for research use before we have finished the regulatory path. And of course, in 2022, we'll reach full sales. The revenue model that we've chosen, and since we have the vision to put this device everywhere, is the following. We'll sell it in a bundle. So we provide the equipment, and we'll sell at volume discount pricing the disposable cassettes depending on how many tests our client needs to do. Our core function will be R&D. We don't want to spend too much time, and we can't, in fact, in manufacturing, so we will outsource it. In terms of distribution, in Europe, we'll use direct selling, and in US, we'll use regional distributors. This is our financial forecast. I want to call your attention to these two moments. So here is the first time that we have a positive cash flow, and by 2026, we already have 50 million euros in revenue. We are the right team to do this because we have many specialties. So Pedro Ribeiro is a physics engineer, he works on the sensors. Nuno Rodrigues will work in the manufacturing process. I am Diogo Caetano, and I'm working on developing the electronics. Of course, we're backed up by many people in our lab, and also we're backed up during this time by João Santos, our management expert, and Nuno Serra and Filipe Vicente, our mentors. This is a picture of my family. I want to keep them safe. Unfortunately, I couldn't do it for one of those persons that is there. But I do think that MagCyte will keep all the other ones safe and with me, and I want to extend that possibility to everyone in the world. I am excited. I hope you are excited. Physicians are excited. They want to use this. That's why this is the right moment for MagCyte to get into the world and start saving lives. Thank you very much.
You have a beautiful family. Thank you so much, Diogo, and your team is coming here too. So any questions in the room for Diogo and his team? Olá, boa tarde. No doubts? Any doubts? You can call Diogo later if something comes up. Okay, thank you very much. Oh, it looks like an auction. 1, 2, and 3.
Hi, thank you for your presentation. It was great.
So
we are talking about lung cancer, and of course that's not the only cancer there is. So what would be your approach to reaching out to other cancers?
Yeah, so we are going to start with lung cancer because, thank you for the question, by the way. As you saw, it's the one that kills the most. But then we will target the others. So the only difference is that we have to find different markers or buy different markers because they are already available. So we will tackle my personal nemesis, which is colorectal cancer, and then we'll go for breast and prostate cancer. So that's in our roadmap, that's what we are planning right now.
Okay. Thank you so much. Thank you.
Thank you.